Okay, in this chromatography lab, the main calculation we're going to need to do is to calculate something called retention factor, which is abbreviated as an RF. And it's essentially the distance that the spot travels relative to how fast the solvent is traveling. So what's happening is the solvent is pulling up your compound, and the solvent is traveling faster than your spot, your compound, which forms a spot on your paper. So it's literally just dividing two numbers. So you measure the distance that the spot traveled, and you divide it by the distance that the solvent traveled, the line at the top, basically. The value will always be between 0 and 1. If you get a value bigger than 1, you set something up wrong. Okay. I literally just sketched an example of what this might look like. And so what you would do is you would measure from the baseline, use the metric system, please. Do not do this in inches. And what you would do is you would measure from where the spot started up to the solvent front. And I already labeled it, but the value comes out to 9.6. Then you're going to measure from the center of each spot. This one happens to have 2. Okay, so from the line to here is 2.2. From the baseline to here is 5.5. Okay, now to do the calculation, what you're going to do is you're going to have 2 different retention factors because you have 2 spots. Each spot gets an RF value. What you're going to do is literally just take 2.2 divided by 9.6, and our relative value, 2 sig figs, would be 0.23. Okay. And this hopefully would be reasonably obvious. If you glance at this, it went maybe a quarter of the total distance. So this is about 23% of the way up. It's essentially how you could visualize this. And then we could do the same thing for the one that's 5.5. You would take 5.5 centimeters divided by the total distance and see what you get. The answer is probably going to be a little less than 0.55. And it comes out to, or sorry, a little more. It comes out to 0.57. There are no units on this because the centimeters cancel out, so it's all relative distances. So, but this tells you as a relative distance how far your spot traveled compared to the total distance. Okay. Now, if we had let this go longer, the solvent may have traveled farther, but these would travel at a relative rate. So even if this went longer, you would still get the same relative distance, which is why we do everything in terms of relative distance. We don't actually care how many centimeters this moved. We care about how it moved relative to the total distance here. And when we get our results of our chromatography in this experiment, I'm going to need you guys to actually measure these retention values. Okay, and I could go through and do all these, but it's literally just this concept over and over and over again. All right, thank you.